All right, picking up where we left off. Trinomials, if a is 1, so here's our scenario. Our c value is -6. That means possible factors of c are 1 and 6 or 2 and 3. I know one of them has to be negative to make it multiply to -6. In order to add to -5, I'm going to need x minus 6 and x plus 1, because -6 plus 1 makes that -5 in the middle. If we have a trinomial where a is not 1, we are going to use the guess and check method. So if I have 3x squared minus 10x plus 8, I know the only way to break apart 3x squared is to make it a 3x and an x. Then I'm going to use factors of 8. I could use 1 times 8 or 2 times 4, and I'm just going to guess about what I think it is. So let's say I think it's 2 times 4. I just need to guess and check the inside part. So 2 times x is 2x. 3x times 4 is 12x. To make that a -10x and a positive 8 here, I can't do it with this. So I gotta try again. 3x and x. Let's try flip-flopping them, 4 and 2. When I check here, I get 4x and 6x. To get a -10x, if these are both negatives, well, that'll multiply to a positive 8, and it'll add to -10. So there's my answer, 3x minus 4, x minus 2. And finally, if we have 4 terms. If we have 4 terms, we combine any, if we can, and then use 3 terms, or we use factoring by grouping. So I group together my first 2 terms and take out the GCF. The GCF of those 2 is x squared, leaving me with 5x minus 4. Then I take the GCF of the next 2 terms. 25x minus 20, I can take a positive 5 out of each of those, which leaves me with 5x minus 4. At this point, these 2 sets of parentheses should match. If they don't, then factoring by grouping won't work. So my first set of parentheses for my factored answer is 5x plus 4, because that's what I'm taking out of these. Then these leftover terms form the second factor, x squared plus 5. And there we have it. We can't factor any further. So let's throw everything all together. We are going to factor this completely. For this first one, we start with our GCF. I can take 3x out of all of these terms. That leaves me with 12x squared plus x minus 1. Don't forget that minus 1. Now there's no more GCF, so the 3x is hanging out front, and I have to use my guess and check method. To break down 12x squared, I could use 12 and 1, 6 and 2, or 4 and 3. I personally like 4 and 3, so 4x and 3x. The nice thing about this one is that to multiply to 1, I know it has to be 1 and 1. So when I check, 1 times 3x is 3x. 4x times 1 is 4x. To get a positive x in the middle, if I had a positive 4x minus 3x, so the 4x and this 1 get the positive, the 3x and this one get the negative. For the next one, 9x squared y squared plus 60xy squared plus 100y squared. Start with our GCF. I can take y squared out of all 3. When I take y squared out, I'm left with 9x squared plus 60x plus 100. No more GCF, so I have to dive right in. Y squared times, to break down 9x squared, I can either use 9x and 1x or 3x and 3x. I'm going to try 3x and 3x first. To break apart 100, I can use 1 and 100, 2 and 50, 4 and 25, 5 and 20, or 10 and 10. I personally look at this one and think 10 and 10. 10 times 3x is 30x. 3x times 10 is 30x. If I add them both, I get that positive 60x in the middle that I want. So this one I could rewrite as y squared times 3x plus 10 squared. Or you can leave it separate as y squared times 3x plus 10 times 3x plus 10. All right, for this next one, I have 2 terms. It's not subtraction, so I can't use difference of squares, but it possibly is a sum of cubes. Is there a number cubed that gives me 343? Well, I am fairly confident that it's 7, but check with my calculator. It is. So our a value is 7x. Our b value, what cubed gives me 1,000? 10. So it's a sum, so I start with a plus b, 7x plus 10, times a squared, 7x squared is 49x squared minus a times b, which makes 70x, plus b squared, which is 100. And there's my answer. For this next one, I look first at my GCF. I can take a 2k out of both of these. When I take 2k, I'm left with 1 minus 16k to the 4th power. Don't forget that 1, it changes a lot. Well, this here is a difference of squares. So I can take 2k times, well, the square root of 1 is 1. The square root of 16k to the 4th power is 4k squared. 4k squared. Difference of squares pattern is that 1's a plus, 1's a minus. But wait, there's more. This is still a difference of squares. So I have my 2k times 1 plus 4k squared. What squared gives me 1? Well, 1. What squared gives me 4k squared? 2k. 1's a plus, 1's a minus. There's my fully factored version. I cannot factor 1 plus 4k squared. A sum of squares does not factor, only a difference. And 2 more problems for us here. This first one, there are no like terms, so we're going to factor by grouping. So I start with my first 2 terms. Take out the GCF. I can take 4x squared out of both of them. That leaves me with 5x plus 12. For negative 5x minus 12, the only thing I can take out is a negative 1. That leaves me positive 5x plus 12. So my first factor is 5x plus 12. My second factor is what was left, 4x squared minus 1. Well, 4x squared is a difference of squares, so my 5x plus 12 hangs out. What squared makes 4x squared? 2x. What squared makes 1? 1. 1's a plus, 1's a minus. There's our fully factored answer. 8c cubed minus 36c squared minus 20c. Take out my GCF first. My GCF is 4c. That leaves me 2c squared minus 9c minus 5. All right, let's try to break this down. The only way to break down 2c squared is 2c and c. The nice thing is the only way to get 5 is 5 and 1. So I guess and check. Let's say I try 5 and 1. I have 5c. I have 2c. That's not going to make my 9. That's not it. Let's try flip-flopping them. 1 and 5. I have c. I have 10c. I want negative 9c, so I could take negative 10 plus 1. It's okay for me to have a negative on one of them because we need to multiply to negative